12 today, actually. We're gonna start with lesson 13, believe it or not. And one of the reasons why we need to start earlier in the first semester is because the AP exam is not exactly in tune with, you know, the rest of the final exams. I think it's a little bit earlier than that. I think finals in May are in the week of the 19th. So May 12th being the final exam, I need to just offset things, you know, for a variety of reasons, so that we are in a comfortable spot when we're finishing up with the course. So we do start lesson 13 and somewhat of lesson 14 before you guys go off into your breaks. But I only test you on lessons 2 through 12, okay? So technically you have to study less than what you're actually even taking quizzes on at that stage, all right? Now, this may change just a slight bit, but here is a general idea for you guys. You're gonna have about 40 to 45 multiple choice questions, and you'll have 5 free response questions. Now, some of them can have only one part because that's all you studied. Some of them can have 2 parts, like for instance, linear motion has a couple of parts that we did for the 2024, but there are a couple of parts we left them alone. So I would only pull those couple of parts and give those to you. I wouldn't give you the whole thing. So I did not write this exam, okay, because I tend to write questions myself too, but I'm gonna give you an actual AP exam that was written at some point in time. And then you guys are gonna be basically taking that as your final exam, and it also is your unofficial mock exam 1, right? So if you get an A on this mock exam, then that tells you that you're sitting at a 5 right now. If you get a B, that tells you you could be a 5 or a 4, so on and so forth. And last year, pretty much everybody got 70 or higher. Okay, so for those of you who've been saying pre-calc is still easier than this, maybe after you take the assessment, you might be like, you know what, this was a little bit easier to study for. Pre-calc is a lot of stuff everywhere, and calc is more linear, like, you know, you learn one thing and then it builds on another thing, so on and so forth, right? This is a non-calculator test. Now, unlike pre-calc, you guys had 2 hours in pre-calc. You're only gonna have an hour and a half on this one, so it's a regular exam. And then finally, you have some support here as opposed to pre-calc, where if you go to the practice test link, which is right over here, this is a secure link. Please, if you have some cousins or anybody else taking this course in any other school, do not share any part of this website with them, because this is a secure link, okay? So the exams are all posted here. Now, they obviously 1969 is quite far back. You don't necessarily need to do that, but I would definitely say that anything that is in these top 5 rows, you should pick it up and you should go through it by yourself. I've done a handful of things here. So if you decide to take the 2016, you click on the PDF right there, and it'll open up into an exam like this over here. And then basically just take it. If it's something that you are like, I've never learned this before, just skip that part of the question and then just keep going that way. And altogether, this is a full-length exam, so it's gonna have 30 questions from the non-calculator, and then it'll have later on 15 questions in the calculator section. Now, because I told you this is a non-calculator test, don't do this. Don't say I won't do the calculator questions in these mock exams, because what often happens is the calculator questions in these mock exams are still, like some of them don't really require a calculator, so you could have easily put them in a non-calculator section. So let me try to find one. Like, here's a really good example, right? It asks something about limits. You don't need a calculator for this question. So this question is fair game on the non-calculator part. I can easily position this on a non-calculator. So because of that, you need to, you know, then look through the entire 45 questions here. And then moving forward, then you go into the free response and you look at the free response questions. Did we ever do something where you have a table and then you tell an approximation for the derivative?
Yeah.
We did. So suddenly you now have to make sure that you know how to do this question. So This is something you didn't have for pre-calc. Now the next one says, you know, if you see the symbol, don't even bother with it, because I'm not gonna ask anything about the symbol on the exam. So I made this a lot easier than I've done in years past, where they had to do from lesson 2 through 14. So you're having to study a lot less than them, okay? So that's a handful of resources that you have at your fingertips. And then once you're done with that, I actually solved all these through the years. So you can go ahead and click on these links, and if I made any typos or anything, I think over the years people have contacted me and I've fixed them and stuff like that. But for most part, if you find something, you're welcome to just let me know that Brother Austin, you made a mistake, and I'll fix it. But yeah, at some point the solutions do start. So from right over there, the solutions start right there. Okay, so and then for those of you who are, there's only a handful of you now, less than a handful, that are still struggling with the class. Most of you are having a very good handle of this. You can click this over here, and I do the same questions on videos. So, oh man, I got 2 more subscribers. Holy smokes! I'm at 85. I was at 83 last year. Man, here we come, 100,000. How many do you need to get the plaque and the mail?
I think the first one's like 10K, and then 100K, and then the other.
No, the first one's 100K.
Yeah, the first one's 100.
99,900.
For the bronze, 10, the silver is no bronze.
Wait, there's a bronze?
I thought there was, but.
No,
I
there's
didn't
all
know.
10K.
How much do I need to get for a bronze?
No,
There
apparently
is
it's
no, I
not.
think it's 10K.
It's
Then
silver
$1
and
million, then $1 million, and then 10 million, and then I think 100 million.
Anyway, I'm just joking. I do, these are private videos, so they're not even they're not even shared on the public whatever of YouTube. I don't care about that. So I did a couple of those in video, and then I did the free response and all that other stuff. You get the idea, okay? So that is a awesome resource for you. Some of you who are already pulling A's in this class, if you got other things to study for, it's not a horrible idea to just go straight to practice tests and just give that to yourself as a diagnostic, and then be like, okay, what am I really struggling with? And then just focus on that part, okay? So I don't think you have to study like so well in advance for this exam as you do for, as you did, if you recall how much you have to study for pre-calc, right? So I think not even half that much. If you start a week early, a week and a half early, you'll be perfectly fine. And another benefit of this is when the AP starts coming closer, you won't have to study so hard for the AP exam either. You're just gonna kind of go straight into it, all right? In March, I believe, we're gonna have another mock exam. And usually I run that through the week. And then in April, we have another mock exam, and that one is on a Saturday. I'll talk to you about that when we come back in January though. Okay, so that's the plan, inshallah, for this exam and how it connects to all the other exams. Do you guys have any questions before we get back into the lesson? Anything that's on the top of your head you want to talk about? Cool. All right.
After the exam, we should have like parties recordings.
I used to take my students outside in AP Calc, and we used to play football. The guys and the girls would sit in a circle, and I don't know what they were doing. Like, that's all right, as long as you're just sitting there. But yeah, I don't mind. It's just Mr. Clark kind of shut down a lot of the activities.
Yeah, you know, they're boring and they hate it.
We can.
No, it's just
They don't want us to have fun.
it's okay. Guys, let's get back into it. I gotta finish this. So I just have a small assignment to do tonight. So last time you guys were here, I was sharing with you a few pieces of information. I said in inverse, the unofficial way to work with an inverse is to do this over here. It's the reciprocal of the inverse's derivative, and then make sure that you don't plug in the same coordinate into it. The other notation, which is more formal, it's from the AP exam. They expect you to know it, so I'm not missing out on this, but basically it looks something like this. It says, if somebody asks you for the derivative of an inverse, that's literally the title of the lesson, you go over to the function and you do the following. You take a derivative of the function, and you plug into it the swapped around coordinate. So that's a more complicated way of saying the same thing that I have over there, okay? So that's the official formula that's in the book itself. Alright, yes?
So on the exam, cause I like your way better, if I do it your way, they will still
Thanks.
give us the points.
Subscribe. 86, man. Alright, yes, what's your question?
So if I do it like your way on the exam, they'll still give me a point.
It's a multiple choice, so.
Oh, so they don't care.
The thing is, the way they ask the question, they ask it like this.
And then
They won't know if you want
Yeah, they don't know.
Cool, let's start. Okay, so I have a little question for you. This is on the AP exam one year, and again, I would say like 90% even kids get this wrong. Partly because it's at the end of the non-calculator section, you're already running out of time, and two, because you have to think backwards for this, and that's not everybody's cup of tea. So it says, you're gonna be making an equation of a tangent line for G inverse, not for G, but for G inverse, and it's gonna be at the value x is equal to 2. So the first thing I wanna start with is ask you, where are you gonna look to find the point? Where are you gonna look to find the point? You know how you need a point and a slope for an equation of a tangent line? Where are you gonna look for the point? Tell me what row you're looking at.
The two.
Over here?
Mm-hmm.
Okay, what are you gonna do with it? You're gonna find g of x? So you're gonna find g of 2. That's equal to 3. What do you guys think? Now keep in mind, if g of 2 equals 3, then g inverse of 3 is equal to? 2.
Orange ones for G of inverse of 2.
Okay, there you go. Now let's start thinking a little different. Alright,
Oh.
so maybe
Yes, I do.
we should look up here. Alright? This is usually the response I hear from people. So think about it like this. The g of 1 is equal to 2. That means the g inverse at 2 is equal to 1. And they want an equation of g inverse at that value. So actually, you're going to be using this combo over here. Okay? So first write that down on your paper. G inverse of 2 is equal to 1. That is actually our point. So 2 comma 1, like that. Alright, now let's go to the second thing. You need a point and you need a what else? Slope. Okay, so now we need to find, let me define the question. We need to find the inverse's derivative at the same point you're talking about. So you're talking about 2. You need to find the inverse's derivative. Now, this is why I wrote the second formula for you guys, so you can sort of have an idea what you should do with this question. So you should definitely put a 1. Now tell me, what should I put on the bottom right there? No, tell me the format first.
After
1 over,
This
f
has
of f derivative of x.
nothing to do with f. This has nothing to do with f. That-
1 over g of g derivative of x.
Okay, thank you for saying x, but we don't want x, we want the number that is gonna go in there. 1, alright, so the number that's gonna actually go in there is gonna be 1 over g derivative at 1, and that's that formula. Whether you look at the top one or the bottom one, that's how the formula actually works, okay? So, go ahead, tell me what is g derivative at 1?
1 over 5.
Alright, so g derivative at 1 is 5, and therefore g inverse derivative at the point 2 is equal to 1 over 5. Like that. Of course, after that, it's really not that hard to make an equation of a tangent line. It's just the thing that leads up to it is so confusing that most folks will not get this question correct, unfortunately. Okay.
Awesome.
You just need to do it enough number of times to sort of just get used to what just happened there. Yes,
I have a
question?
question. Why didn't we do F derivative in the denominator? Does you know what usually do?
Because it's
The
an
question says that G inverse is the inverse function of G. So it just, the F values are there, but they're unnecessary to us. You
Well,
don't
look,
need
the
them.
first two.
Oh, you were looking directly at the equation? No, you should look at the problem though. It says, it doesn't say F is the inverse function of G. It says G inverse is the inverse function of G. So then you're just looking at the G values there and the G derivative values. It has nothing to do with F anymore. They're just there. It's extra information, yes?
So like in that one, G inverse was derivative function of F.
Yeah, that was where, if you guys remember on Friday, I said F and G are inverses of one another. I had you write it down like 5 or 6 times, so that you realize that when somebody tells you it's an inverse, then you can go ahead and treat the values as swap around coordinates. If I never told you that, then you can't use their coordinates anymore. Alright, so again, very confusing example. Make sure you study it again and see how I went about it. Alright, now your turn, okay? I know how that can be very confusing. This is, once again, look at from the end of some exams. I have to fish around a lot to find these examples. It's not a whole lot of work you need to put into it. You just need to think it through. And they'll almost always have the incorrect answer that everyone thinks is correct in the beginning. See, now here it tells you F inverse is the inverse function of F. So it has nothing to do with G anymore. Technically, you would have like 2 minutes to do it, but because we're directly learning the lesson. What do you guys think?
B.
Over negative.
B.
Oh,
C.
Alright.
C. I got,
How's it C? Because
C, how is it?
I got B.
Or how is it not to show us? So F inverse of 2, you're looking at it, the derivative, so you're gonna say, okay, first of all,
Yeah, right.
let's talk about the function, alright? There is some function that it goes through something and its answer is 2. And that's why the inverse must be look, whatever number you put in here, you're gonna put over here.
it's 1.
Now tell me,
Yeah.
what number goes right here?
1.
1, okay, so you put a 1, put it. So that's the thing you have to do. You have to write that down a little bit and then be like, okay, this is a 1, like this. Then you go over to either formula, just you have to understand how the formula works as well. I just gave you 2 ways to look at it. You have to say, okay, 1 over F derivative, definitely not at 2 anymore, but at, again, see, look, the function itself never goes through 2, it goes through 1. So that's why you put that 1 right over here. So you write down the F derivative at 1, like this. And then of course, now you can use the table to tell what the answer is. So what's the answer to this one?
B.
Over
Negative 1 over 8.
Negative 1 over 8. Question, do they have the wrong answer if you had found F derivative at 2
Yeah, that was C.
instead? That was C, alright, so they'll pretty much always do that. The answer choices are very close. Questions? So here they're not asking you for the equation of a tangent line, they just want the slope itself. I think a couple more questions. We're gonna circle back to this one. This is the most difficult one of the mix. So I wanna first do this one with you guys. This one is a lot easier. Here, again, to the people who asked, I've given you both ways that they tend to ask this question. Here it says G is the inverse function of F, okay?
What would be lesson 11 and 12? Or did you just lesson?
This week's quiz?
Yeah.
Yeah, I think I'll throw a little 12 in there too, sprinkle it on.
I was thinking.
11 is a big lesson. I'll tell you the more details about the quiz. Okay, so again, I've tried different strategies every year. Every year, when people don't do that well, I think of more strategies. So first I want you to look at that chart. F of what equals 2, you guys? You see how I did this? Then go over here and stick a 1 into that spot. Okay? So now what's the answer?
A.
A?
Yeah.
Alright, now let's go to the most difficult question that I have seen on inverses. I will not say much. You're welcome to talk to your friend.
Is this a calculator problem?
No, this is a non-calculated problem.
Yeah, but also, how do you know that G is 1 equals 1?
Oh wait.
I'm talk to your friend, man. Don't talk to me.
You don't have your
I'm not your friend. I'm not your friend. You're not a friend.
Yeah, bro.
You're supposed to learn equation time or we take the derivative of it.
Wouldn't you just equal f of x to 1 and you
Yeah,
just
this is supposed to be left empty.
Oh yeah, see?
Yeah, how do you equal f of x to 1? I can't solve it.
because if you
No, you do, but then how do you solve it? You get sine of x is
Everyone's
equal
a friend.
to negative
you get sine of x plus 2x
is equal
equals
to 0.
0.
Yeah, how do you solve that?
I had the same problem.
I mean, you get there, and then how do you keep on going?
Well,
Do you see how they have 2 plus cosine, so they don't even end up finishing solving at that point. They just equal this to 0 and then.
So we know for sure the answer's not C, and we know it's not gonna be E. The answer could be either A, B, or D.
How do we know that?
Because usually it's like 1 over something, so it's not gonna be like 6 over 2 to make the answer 3.
Bro, this is because D or something.
Oh my god.
No, it's A, B, or D. Those are the options.
Wait, what if we find the, you know, if you switch all the x's with y's and you switch the f of x with x, you can find the inverse function itself, and then,
Yeah, we're doing. I would have never done that.
you know, that would work.
He did equal it. Oh, it doesn't work.
No, but once you do that, you're I know it's
No, I'm just saying.
you just got x equals 0 to
I'm
0.
stuck there, I'm like,
Because
Bro,
Sine of
So,
0 is
I guess
0.
we're doing
So the
this
answer's B.
together.
I told you guys.
So I guess we're doing this together. So one of the things you guys will realize is if you just try to stay consistent with what I've been trying to say to you, right? And even for most people, even that's a hurdle. But I think you guys are at least understanding that part. Look, you know that f of something must have equaled 1, and that's why they're asking you g of 1. So you need to backtrack and say, well, what exactly did I plug in here to make it equal to 1? The only way that will work is you actually have, because you don't have a table here, you physically need to take that equation and equal it to 1. Now the 1's cancel out, and yes, you're right, there is no way to solve this equation by hand, but you have to just look at it and be like, the only number that will fulfill this criteria is the number 0. So when x is 0, the sign of 0 is 0, and 2 times 0 is 0, so you're like, okay, that number must have been 0. Then you go back, and I think you know where this is going, but basically that number is 0, and therefore this number is 0, and therefore what goes into that derivative is going to be 0. Still not quite done yet though. What do you still need to do with the f function?
Negative cosine of 0 plus 0.
So this becomes, what a well-written question. So I appreciate a good written question right there. So that becomes f derivative of 0, which is equal to cosine of 0 plus 2. What does that give you?
So how's it?
Three.
Gives you
Oh,
3.
so over 3.
So
It's
now
eight.
take this
Wait, why did you say?
and plug it in right there.
Yeah.
Okay. Yes, what's your question?
Didn't you say the answer was 1 there?
I didn't
That's the
say
f
the
of
answer is 1. I said
Oh,
that f of x is equal to 1. So we have to backtrack and figure out what's the number that makes f of x equal to 1. And the number that makes f of x equal to 1 is the number 0. So f of 0 equals 1, that means g of 1 is equal to 0 because they're inverses of one another. And once you get that understood, then you can go ahead and update this formula, but it still doesn't end there. You still need to take a derivative of the f function and plug in 0 into it to get a final answer, okay? Again, I think this is hands down the most confusing lesson you'll ever learn in calculus, which is the derivative of the inverse function. And I brought in every type of example that I've collected over the last 10 some years to find it, to make it easier for you. Your homework for tonight, please don't pack up yet, we have 10 minutes. Your homework for tonight is this one over here.
Lawson, it's the easiest AP homework you could ever have. I finished it in like 15 minutes.
You may want to just go back and just make sure after today's lesson that maybe you thought it was easy, but it was not actually right.
No, but all of them were like f for the f inverse of g.
Look, I spent 2 days on it, but you know, most of the time when I give the question on the AP and mock exams and stuff, this is one of the questions that pretty much the whole crowd gets wrong. So, you know, spend some more time with it. Change that norm, inshallah. You guys are really strong classes here. Yes, Yakub. Sure. Okay. Guys, I think this is new this year. I do not know what this is. I think these are recordings from, these are recordings from last year. Basically what we do in Calc BC is we finish a week early with the work, and then we just sit there reviewing a bunch of questions. So you don't have to watch the review. This is more designed for when you're getting ready for the AP exam, but if you want to, you're welcome to. I just thought it'd be nice to put that there. And so that's it. That's the end of differential calculus, okay? And we start today with integral calculus, okay?
Is that the little sign?
Yes, that is the little sign with the symbol. Yeah. Where have you ever seen that symbol?
In the practice exam.
The practice exams?
Yeah.
And also all of what the chalkboards.
It's all over the chalkboard?
Yeah.
Oh, and in
Not
the
this year, last year.
no, and this year
Last
in
year,
the
yeah,
AP
I was in Sister Lori's room. So.
Yeah, that's true.
No, we see it this year in the when we have chemistry.
Yeah. And we see some crazy graphs with
And like a
red and
heart.
green.
In the Arabic club.
Yeah.
Oh yeah, it's like you're graphing out a heart. This one was like a
Yeah, it's called a cardio.
Yeah, no, someone's telling me that.
Yeah. So you know how you have functions of families, like the square function, the cube function, the square root function? So there's a different way of looking at them, called the polar family. Inshallah khair, let's go ahead and start with the second part of calculus today, alright? And of course, in the time I have, it's just a brief introduction for you guys to think about something. So, just like the first lesson pretty much was basic differentiation, this is called basic integration. We will learn a few rules about integrating. Today though, what I want to do is just spend a little bit of time to help you understand where we got integration from. So I have a little app for you. I hope it doesn't backfire like the one that did on Friday. It turns out the problem is not the app, it's actually this interface. This thing is just not a good computer. So, here we have a little function for you. It says h of x is equal to 10 minus 0.05 x squared, alright? And basically integration in one word is area, okay? So just like you guys have learned in the past that the differentiation is slope of a line that is tangent to this curve. Now we're actually looking underneath that curve, and we're picking up area all along the curve. Now, usually, you know, another title for this class is not calculus, it's called analytical geometry. If you look up this course in UWM or UW-Madison, they call it analytical geometry. So this is actually, calculus is another geometry course, okay? In fact, you learn slope in geometry, you learn slope here. You learn area in geometry, you learn area here. You learn volume in geometry, you learn volume here. The only difference between then and now is before you used to have simple shapes, okay? So think back to when you were ninth graders. I know this seems like a very long time ago, but if I gave you this rectangle, it doesn't require any calculus, but you would just say, okay, just give me a width and give me a length, and I'll go ahead and I'll multiply the two out, and I'll give you the area of this here rectangle. Where things start to get more and more confusing is when we start to give you something that isn't necessarily like that. It might be something that's somewhat shaped like a rectangle. Let's suppose it's something that looks like this over here. So then you're like, well, I can't tell you exactly what the area is, but I can ballpark it. I can tell you that you've got a little extra area there, you lose a little bit of area there, and then I can give you a general idea of how much the area of this curve would be over here, right? So you could give me, maybe you could cut this off in some way, and people try different sorts of things to just have a general idea what the area should be. Obviously, that is just an approximation. So just like we approximated slopes before, we're going to approximate areas using different types of methods that have been developed, right? So basically, what we do is we take any curve that's given to us. So let's suppose a curve that looks like that over there, and we make a bunch of little rectangles underneath it. Okay, so we say, all right, let's start from point A. So I start from point A, and let's go all the way to point B. So then we stop at point B, like that, all right? And then what we start doing is we start making little rectangles underneath that curve, okay? So we can start from over here. We can say, all right, let me make one rectangle over here. And then we say, okay, let me make another rectangle over here. Now, are all these rectangles the same size?
No.
They're not, right? So what ends up happening is you have a bunch of rectangles, and they're not all the same size. But here's my next question to you. As I'm making these, how would you be able to tell the height of these rectangles? I know they're all different, but how could you tell the height of these
With the
rectangles?
y-axis?
Where they touch the line.
Right? So if you looked at the function, if you looked at where the function is, you'd be like, oh, I can tell what that is. So essentially what ends up happening is in these rectangles, you can actually tell the height of these rectangles. What you used to originally call a width back in geometry, we call that a height in calculus. You would say that the height of this rectangle is basically the function at x. So tell me the y value of the function, plug in the x, find me the y value, and I can tell you what it is. And these little pieces over here, these are very small little pieces. Okay, they're very small little pieces, and technically they're supposed to be called change in x, but then what we did in calculus, we changed it to dx. Just like we used to have dy over dx, we just basically take that little part right there, and we say that the length of that rectangle is going to be dx, and they're all dx. So if you start thinking about it, the fact that there are so many rectangles and each one of them is going to have their own different height, well, what will happen is you'll tell me, yeah, I can find you the area of this rectangle, but then you're just going to give me another rectangle, and then that's going to have a different area, and then the next one's going to have a different area. So integration is this really beautiful technique of saying, how about this? Let's take all of the rectangles and all of their areas and actually sum them up. All right, let's sum up all the areas. So this symbol over the years has changed, where they basically took what used to look like the letter S and they started to make it more and more slender, so it started to look like that. So that actually is an S. for those of you who said you saw the symbol. And this tells you where you started taking the area, this tells you where you finished taking the area, and it basically says, I'm gonna sum up all the areas of all the rectangles I get, and so that in a nutshell is integration, okay? And so you spend basically about a year, you know, half of this year and then half of the next year, just learning all kinds of different integration techniques. And eventually you have collected all of the area underneath the curve over there, okay? We'll stop here and we'll pick up, don't forget to do your homework.